So right now we are going to discuss the acidic strength
Yes, sir.
of different carboxylic acid. Let me write acidic strength of carboxylic acid. So there are some questions. Just look at the question: acidic strength of carboxylic acids and their derivatives.
Mm.
So just go through the question. We will be doing it one by one. Is that fine?
Yes, sir.
Okay. So these are the questions. Just write them somewhere, and so that we start doing. So 1, 2, 3, 4. There are 4 questions, but they're sounding very similar. So let's start doing. Okay. Let
Yes,
me
sir.
have you taken the snapshot?
Mm. Yes, sir, I have.
Just take a snapshot. So we move to the white sheet now. And you tell me what is the first question. Aditi, tell me what is the first question.
So CH3COH.
The first question is
So ethanoic acid or
ethanoic acid and
CH2FCOOH.
so that is CF or CH2F and then COH. This is the compound. So this is compound number 1 and this is compound number 2. This is 1, 2. This is 2-fluoroethanoic acid.
Ethanoic
This is
acid.
2-fluoroethanoic acid.
Mm.
And this is ethanoic acid only. So out of 1 and 2, which is a stronger acid? So we know that when fluorine, this compound is going to lose a proton. So when it will lose a proton, something like this is obtained. Is it
Mm.
fine? Is it fine?
Yes, sir.
And fluorine has an inherent
Mm.
intrinsic characteristic of withdrawing electron through minus I. So this will
Yes, sir.
withdraw, keep on withdrawing electrons. So the negative charge on oxygen atom is kind of getting delocalized to the whole molecule. When it is delocalized to the whole molecule, the stability of negative charge increases. The more is
Mm.
the stability of negative charge, more is the willingness to lose proton. So this is more willing to lose proton vis-a-vis an ethanoic acid. That is why 2 is a stronger acid than 1. So
One.
quickly note it down somewhere. So it is the fluorine atom which is withdrawing the electron cloud away from the oxygen negative charge such that the negative charge is getting delocalized or dispersed over the whole molecule and thereby enhancing the stability of negative charge. And as the negative charge is more stabilized, this is more willing to lose proton. And when it is more willing to lose proton, this is subsequently a stronger acid than ethanoic acid itself. Quickly note it down somewhere. So the golden rule is whenever a carboxylic acid is attached with an electron withdrawing group, the acid strength definitely goes up. Looking as right. And the
Yes, sir.
counterpart of the concept is whenever a carboxylic acid is attached with an electron donating group, the acid strength decreases. So these are two complementary statements. Quickly note it down somewhere. Is that okay?
Yes, sir.
Right. So since fluorine is electron withdrawing group, so that is why it is enhancing or increasing the acidic strength. Tell me the next question now.
So next one is
Mhm.
uh, CH2FCOH or CH2ClCOOH.
CH2FCOOH, which is 2-fluoroethanoic acid, and the counterpart is CH2Cl and then COOH. So this is 2-chloroethanoic acid. So these are
Mm.
the two compounds you have to find out the acidic strength. Now you know that fluorine electronegativity scale, fluorine is definitely more electronegative
More
than.
than
So
chlorine.
this is determinant number 1. Point number 2, when fluorine is more electronegative, what happens when the compound number 1, 2-fluoroethanoic acid, this is 2-fluoroethanoic acid, write it somewhere, and this is 2-chloroethanoic acid. So what happens to fluoroethanoic acid post loss of proton, something like this type of a conjugate base is obtained. And since fluorine is electron withdrawing, so this electron withdrawal What it does is this delocalizes the negative charge to the whole molecule to a larger extent with a chlorine atom whose electronegativity is lesser. Do you understand this?
Yes, sir.
Because chlorine is less electronegative, even this is withdrawing negative charge, but the extent of delocalization is lesser. This size of arrow is meaningful. This is delocalized to a lesser extent with a fluorine atom. So when the negative charge is more delocalized, in case of compound 1, the negative charge is more stabilized. And when the
Stable.
negative charge is more stabilized, it is more willing to lose proton. And when it is more willing to
Hmm.
lose proton, it is less willing to lose proton. So when it is more willing to lose proton, it is definitely a stronger acid. So one is a
Stronger
stronger acid.
acid.
Yes. So 2-fluoroethanoic acid is a stronger acid than 2-chloroethanoic acid. I hope it is clear. Is that fine?
Yes, sir.
Right.
Yes, sir.
Right. Next question.
So next is CH2F CH2 CH2
CH2F, CH2,
CH2
CH2,
CH2
hmm,
COOH
COOH. So this is virtually one, two,
and
three, four. 4-fluorobutanoic acid.
butanoic acid.
4-fluorobutanoic acid, right?
Yes, sir.
And what else?
And
This
the other is
one,
CH3CH
CH3, CH,
CH
mhm,
FCH2
FCH2,
COOH.
COOH. So this is one, two, three, four. So this seems to be a 3-fluorobutanoic acid. So this is compound number 2. You have to find out which is a stronger acid. So now you can see here in compound number 1 and 2, compound number 1, fluorine is far away from this carboxylic acid group. So what is happening when compound number 1 is losing a proton? What do you get? First of all, we need to write that. What do you get is a carboxylate anion, and fluorine sitting far away from here. What about compound number 2? It is again losing a proton, and there is a remarkable difference. The distinction is the fluorine is closer to the negative charge with
Hmm.
compound 1. Is that fine?
Yes, sir.
So when fluorine has moved closer to the negative charge, it would be more proficient to withdraw the negative charge because of closeness, closer proximity. So this negative charge is more delocalized in compound number 2. More is delocalization, more delocalization of charge. This implies more stability. And more is the stability of negative charge, more is the willingness to lose proton. And
Loose
when it is more
proton.
willing to lose proton, this is thereby a stronger acid than 1. So a 3-fluorobutanoic acid is a stronger acid than 4-fluorobutanoic acid. And this time
Butanoic acid.
yes, and this time the acid strength is governed by the lesser distance of
Distance.
fluorine atom to the carboxylic acid group. Okay?
Yes, sir. Yes, sir.
So we can say if distance decreases, the magnitude of inductive effect increases. Write it somewhere. This is the concept involved in this question. Their distance and inductive effect are inversely proportional to each other. Is that okay? So this is
Yes, sir.
question number 3, and then move to next question. Is it the last question?
Yes, sir.
Mhm.
So there's CF3
There is a CF3
attached to benzoic acid.
attached to benzoic acid at what position? Fourth position.
4. Yes, sir.
So CF3, 1, 2, 3, 4, something like this. And what else?
Yes, sir.
What else?
So the other one is methyl group at fourth position of
At
benzoic
fourth
acid.
position. Okay. So we have a methyl group here. 1, 2, 3, 4. Now concept is same. As we can see in 1 and 2, in compound number 1, post loss of proton, again you are going to get a carboxylate anion, rather benzoate anion here. 4 position is occupied by CF3. CF3 is strongly electron withdrawing in nature because of minus I effect ability. So this negative charge is kind of withdrawn towards CF3 group. So
Hmm.
this negative charge is getting delocalized. More delocalization of negative charge means what? More delocalization.
More stability.
this implies more stability. Stability is increased. So when stability is more, the ability to lose proton is more. When it
More.
loses more proton, this is a stronger acid than 2. So 1 is a stronger acid than 2 because
2.
of presence of CF3. CF3 is causing enhanced inductive effect, electron withdrawing inductive effect, which is minus I, and that is why the negative charge is extremely stabilized with respect to compound number 2. And when it is more stabilized, it is more willing to lose proton. And when it is more willing to lose proton, it becomes a stronger acid. So 1 is a stronger acid than 2. So this is all about the acidic strength in these 4 compounds. You can quickly revise them and we can move ahead. Is that fine?
Yes, sir.
Okay.
Yes, sir.
So quickly revise so that we will move ahead now. So this is done. Just go and
Yes.
revise this here.